All right, so now for this year, I think this year was actually a very sweet year. All right, so it's actually a very sweet year. Basically, all the questions were understandable. All right, so in this one, students were asked to explain the process of urine formation in the kidney, and it's quite easy. All right, I think it's about five steps like that. Right. So for here, they are just trying to talk about how urine is formed in the kidney. All right. So um, I think this actually explains it better. The blood, everything is supposed to come like this, afferent towards, okay? Once you come here to the glomerular filtration side, okay, or the glomerulus, it now filters out. Okay, sorry, this is the blood that comes, this is the blood that goes out. So the filtrate will enter here, and all the process that will lead to what? The final product that will now come to the bladder. Okay, that's what they actually ask the students to talk about. So it's quite sweet because once you know it, you know it. Okay, so let's have the overview then walk through the five steps that are involved in urine formation. So the kidneys are actually an amazing filtration unit, crucial for maintaining the body's homeostasis by forming urine through a precise and intricate process. Okay, so if you always see the way I answer questions, I always start with the introduction. So you are not scattered. He said, okay, talk about the steps. Just start writing the steps. At least make the person reading to actually what feel at home again. So the first process is what? Filtration. And this filtration occurs in the glomerulus. Okay. So this process now, body enters the glomerulus through the afferent arteriole. That's the arteriole that is coming. This one. The one that is going is what is known as efferent. Okay. So blood enters through the afferent arteriole, and the pressure forces the water and small solutes to come out of the blood, enter into the Bowman's capsule. You get, forming the filtrate. So here you can see the root F. F is what? Filtrate, okay? Filtration, that's blood going into the lumen, right? So here there's another resistant membrane here that should repel all the proteins, or basically almost all the proteins. Okay, but if the membrane is destroyed, that's when you'll be having all those proteinuria. Okay, but that one, don't worry, we'll discuss it another day. So large molecules like proteins and blood cells still stay in bloodstream. Okay, so even if they are filtered, just very small. Okay, then reabsorption. Next now is reabsorption. Things went through, but probably the body still needs some of these things. So as they are coming here in the proximal convoluted tubule, that's the PCT, the body will be like, hey, some salt actually went in, but I still need some salt. Okay, so you now send some salt back. You understand? So reabsorption is, and the location is the proximal convoluted tubule. All right. It occurs at the proximal convoluted tubule, occurs at the loop of Henle, occurs at the distal convoluted tubule. Now let's discuss this. Proximal convoluted tubule, it comes down. So the body might change its mind that, okay, no, I still need some things. So send them back. So at this level, still send them back. At the distal convoluted tubule, the body will be like, hey, I didn't need something at this side, I didn't need, but I still need it, or I still send it back to the body at this side again. So reabsorption occurs at what? Three locations. So this process is what? So in this process, essential molecules and ions are reabsorbed back into the bloodstream from the filtrate because the body still needs them. Okay. These include essential molecules like what? Glucose, amino acid, and various ions like what? Sodium, potassium, calcium. So water reabsorption also occurs, particularly in what? Loop of Henle and collecting duct, okay? Driven by osmotic gradient, okay? The last one is what? Secretion, all right? So secretion. Secretion occurs in the proximal convoluted tubule, in the distal convoluted tubule, and the collecting duct. This is the collecting duct. This one down, okay? This one down. Let me say, for example, they give you an exam in the hall. So you guys sat like that, and they said that send your answer papers to the people at the front. So the examiner will just pass and collect. Do you understand? That's the work of the collecting duct. Collecting duct is just a passage. Another unit of nephron will come and join. Another unit of nephron will come and join. Another unit of nephron will come and join. You get? That's why they call it a collecting duct. So the process is additional waste products and excess ions are secreted from the body directly into the tubules, right? And this helps in maintaining what acid-base balance and removing toxins and drugs. So not everything must be going through the through the Bowman's capsule. You get some things can actually bypass this glomerulus, okay, and actually be secreted directly into this place. You get. Then next is what? Concentration. As the urine gets into the collecting duct, it has to be concentrated. Okay, so the final urine concentration is adjusted. So antidiuretic hormone regulates what? Water reabsorption. So if you are thirsty, the urine you will produce will be very concentrated and the color will be amber. You get. So if you are not really thirsty, the urine you produce will be very white and all of that. Right? All of that is done at the collecting tubule and is regulated by the antidiuretic hormone. All right. So antidiuretic hormone regulates water reabsorption to concentrate the urine, and this is based on the body hydration status. Then excretion is the last one, which is from the renal pelvis to the ureter. Okay, so the final urine, composed of water, salt, and waste products, is produced in the renal pelvis and transported to the bladder via the ureter for eventual excretion. Right. So this actually talks about the process of urine formation in the kidney.